Hi, and welcome to ArcStar, home of the best quality, most complete, and easiest to use plasma tables. In this video, I'm going to show you how to design and cut a completely custom part. Now, for the sake of this video, we're already assuming we've looked in the parts library and we couldn't find anything that we exactly wanted, so now we need to design a custom part. All right, so we'll start with an overview of the 3 steps in the plasma design and cut process. First off, we need to design the part. This is referred to as CAD or computer-aided design. Second, we need to add the cut paths. This tells the plasma table where and how to cut the part. This is referred to as CAM or computer-aided machining. The third and final step is how to control the plasma table. This is referred to as CNC or computer numerical control. On some of the competitors' plasma tables, this process requires learning 3 separate software programs, each of which is completely unrelated to the other. For ArcStar, one single software program does everything we need all in one easy-to-learn package. All right, so let's go to our computer and see how simple this is. We'll start by double-clicking on the Vectric Cut 2D Pro icon. The first thing I need to do is to click on Create a New File on the upper left-hand margin. This automatically opens up the Job Setup menu, which is where I input the job parameters. Essentially, this is where you set up your workspace. The only thing I really need to enter here is a rough estimate that's larger than the part I'm designing. So first, next to units, I'll specify inches. And then for job size, I'll enter a width of 16 inches, a height of 8 inches, a thickness of 0.1 inches. I'll make sure my XY datum position is set to the center, and then click OK. So this brings us to the main program. Notice on the left margin there's a whole bunch of drawing and editing tools. This is the CAD or design menu where you draw your part. If you look at the top of the menu box, note that it says Drawing. Now the first thing I want to do is to draw a rectangle. If I look in the Create Vectors section, I can see what looks to be a rectangle, and when I hover my mouse over it, a pop-up box reads Draw Rectangle. That's what I need, so I'll go ahead and select the tool. So now at the top of my CAD menu, it tells me that I've opened the Draw Rectangle menu. Now I could always just freehand click and drag or sketch an approximate size rectangle on my workpiece, but for this project I want to designate an exact size. So in the Draw Rectangle menu, I'll check to make sure the anchor point is in the center. I'll make sure the X and Y anchor point coordinates are both set to 0. And then I'll input a width of 6 inches. A height of 4 inches, and then click on the Create button. So that's exactly what I wanted. So to close the rectangle tool, I can either click the Close button, or better yet, do a right mouse click. Either way does the same thing. Now, I want to add 4 1-inch diameter holes, one near each corner of my part. Under the Create Vectors section, I'll click on the Draw Circle tool and then specify a diameter of 1 inch. Now, I want the center point of my 4 holes to be exactly 1 inch away from each side of the part in each of the 4 corners. Remember, during the job setup, we set the XY datum position to the center of the part. If we look at the edges surrounding the workspace, we can see on the scales that the X and Y 0 points intersect at the center of the part. Mathematically, that means I'd like the center point of the top right circle to be at position X equals 2 and Y equals 1. If I hover my mouse over the approximate position I want the first circle to be at, I can see that if I'm really careful, I can get the coordinate readout on my mouse position to be approximately equal to that value. But how do I get an exact position? Well, that's the beauty of what's called smart snapping. On the toolbar menu at the top of the page, the first three icons control which smart snapping features are toggled on or off. There's geometry snapping, smart snapping, and grid snapping. For this project, grid snapping would be the best choice. So I'll click on it, and now I can see a whole grid of light gray dots or snapping points on my workpiece. So let's check the grid distance. Pressing F4 opens the snapping options box. Here I can change the grid spacing to be whatever works best for this project. Let's change the grid spacing to 1/2 inch. I'll press the OK button to close the snapping options box. Now if I hover my mouse cursor near a grid point, it seems to sort of snap onto the point, and I can see the cursor changes from a circle to a solid square dot. And if I look at the mouse cursor XY coordinates, I can read the exact location of the point it's snapping to. Alright, so let's click on the grid point that I want to snap to, which is the X = 2 and Y = 1 position. So now my 1-inch diameter circle is placed exactly where I wanted it to be. So I'll repeat that at the remaining corners of my part. That looks great, so I'll right-click my mouse to return to the drawing menu. Next, I want to add a radius or fillet to each of the corners. Underneath the Edit Objects section, I'll select the Fillet tool. I want all my fillets to be a 1-inch radius, so at the top of the menu, I'll enter a 1 for the radius. Next, I simply move my mouse to each of the 4 corners. When the cursor gets close enough to detect them, a check mark automatically appears next to the cursor, meaning that the program has detected a corner. When I see the check mark, I simply click on the corner and a fillet is automatically added. Well, that looks great, so I'll right-click the mouse to exit the Create Fillets tool. Finally, I want to create a 2.5-inch diameter circle at the center of my part. I'll click on the Draw Circle menu, change the diameter to 2.5 inches, and then click the center of my workpiece to draw the circle. So now that I'm finished with the Draw Circle tool, I'll right-click my mouse, which brings me back to the drawing menu. So at this point, we're done drawing the part, but I still need to do one more thing before I move on to the CAM process. Right now, I've created 6 separate shapes. If I click on any of them with my mouse, you can see how they'll individually turn to a bright pink dashed line. But I don't want 6 separate shapes. I want it to be a single shape. So what I need to do is to group them together as one. In order to do that, I'll click and drag a box around all of them and then release the mouse button. You can see that they're all pink dashed lines. The pink means that they've been selected or clicked on, and the dashed means that they're still all individual shapes. So if we look over in the left drawing menu under the Edit Objects section, there's a group icon which looks like several different types of shapes with a chain link. And the pop-up window identifies it as Group Selected Objects. So let's click on it. And when I do, it immediately groups the individual shapes together as one. I can see in my workspace the lines are no longer dashed, but instead they're all solid, which means they're one whole part and not separate pieces like before. Alright, so that completes the CAD part of the design process. Next, we need to go to the CAM part of the program. At the top of the CAM menu, to the right of where it reads Drawing, there's an arrow pointing to the right. And if we hover over it, the pop-up box reads Switch to Toolpath Commands, which is exactly what we need to do. So go ahead and click on it. Now we've opened the toolpaths, or the CAM part of our program. If we hover over the very first icon underneath the toolpath operations section, we see that it's the Profile Toolpath button. That's exactly what we need to do, so go ahead and click on that. Now this is where we're going to tell the plasma table how to cut our part. Let's go down this menu top to bottom. The top section is labeled Cutting Depths, and we want to make sure the cut depth is set to 0.1 inches. Now, just to be clear, this has nothing to do with how thick the material we'll be cutting is. We just want to make sure the program only makes one pass to cut out our part. Hence, we need to make the program think that the material is fairly thin. In plasma cutting, you only cut a line once. You never go over it a second time. The next thing we need to do is to check the box labeled Show Advanced Toolpath Options. This displays the Leads tab further down in the menu. The next section is the Tools section. This is where we can choose a tool, but because we compensate for the kerf width with our controller, it really doesn't make any difference which tool we choose. The only thing we really need to check here is that the number of passes equals 1. In the Machine Vectors section, select On and click Climb as the direction of cut. Next, click on the Leads tab. The first thing we need to do is to check the Add Leads option box. We want to check Circular Lead and then enter a radius of 0.2 inches and a lead length of 0.4 inches. Next, check the box enabling Do Lead Out and make sure the overcut distance is set to 0. Finally, at the bottom of the CAM menu, check the Calculate button, and then click the Close button. Now the default view is probably changed to 3D. For us, everything we do in Plasma is in 2D, so it makes the most sense to click on the 2D View tab at the top left of the page. And as soon as you do that, you should see the cut path directional arrows drawn exactly on top of the part lines. The green boxes are the start points of where the torch will first pierce the material for each of the cuts. Now if you look closely, you can see the light gray lead-in and lead-out lines that transition the torch from the pierce point to the actual lines of the part. Because the pierce hole is larger than the kerf width, piercing away from the part and getting the torch up to speed before it's actually making a cut on the part helps to maintain the highest cut quality possible. That's why we want to make sure and use lead-ins and lead-outs as much as possible. The last step in the CAD/CAM process is to save the toolpath. To do this, click on the bottom right Save Toolpath icon that looks like an old computer floppy disk. In the bottom right corner is where we need to choose the correct post processor from the drop-down menu. Now because we were running our plasma table in inches or imperial units, we'll choose the ArcStar Inches post processor from the drop-down menu. Next, click the Save Toolpaths button, and now we need to navigate to where we want to save the file to. In this case, we're going to save it to a USB stick. And then we type a file name. In our case, we'll call this 5-hole bracket. Click Save. Now, although we just saved and named the toolpath, don't forget to save the project before you close the software. To do that, just like any other program, click File and then Save, and then as before, type a file name, click Save again, and then you're done. All right, so congratulations. Perhaps you just completed your first CAD/CAM design part. Now, that wasn't too hard, was it? One thing that really makes Vectric the best choice is how we stay in the same program the whole time for both CAD and CAM operations. Another huge advantage that you may have noticed is that we haven't yet had to program any speeds, heights, or voltage values. These are all set by our controller, which means that we only need to design our part one time. Now with other plasma table software, you have to specify the exact cut speeds and heights right when you draw the part, which means that you have to redesign the part and have a completely different program file for each potential thickness or type of metal you eventually want to cut. This means that you may very well have over a dozen or more different configurations of the exact same part that you need to keep track of. But with an ArcStar table, the part design always remains the same no matter what type or thickness of material you end up cutting later. It's much simpler that way. Now, another consideration is what happens if at a later date you want to modify or change the part. Well, again, with ArcStar, you'd only have to go back once and change the part design one time. With the other guys, you'd have to redesign the part and then modify all of your files for all of the different types and thicknesses of material. The bottom line is that the ArcStar single software solution greatly simplifies the CAD and CAM drawing process and greatly reduces the risk of making mistakes. All right, so the next step is to go cut our part. We'll see you in the shop. So here we are with our plasma table. I've already turned it on and I've inserted the USB stick into the front slot. I'll press File, then choose USB disk, and then push the blue Enter button. Turn the exhaust fan on, and then push the green Start button. And here's my custom designed part ready for installation. All right, so that wasn't so difficult, right? Now, a couple of things I'd like to mention. Our goal today was to make an introductory video showing an overview of the workflow process, especially for folks that may never have been exposed to it before. For that reason, we didn't go into a lot of details that the software is more than capable of handling. For example, we didn't talk about designating start points, changing the cut order, nesting, converting raster images to vector images, Bezier curve manipulation, etc., because we didn't want to overwhelm anyone and we didn't want to get bogged down in minutia. Plus, we didn't want to create a 2-hour video that no one would watch. The other thing we didn't show is how to check the settings in the controller, like changing the speeds or the arc voltage. Well, if you've been repeatedly cutting the same type and thickness of materials, the settings don't change, so there's really nothing to check. However, if you're interested in seeing how to do this, we do have a separate video that shows exactly how easy it is. All right, well, thanks for taking the time today to watch our video. If you're seeing this on YouTube and you appreciate the job we've done, please make sure and give us a thumbs up. Don't forget, get a lot more information about plasma tables on our website at www.arcstar.com. So remember, when you're in the market for a professional grade, easy to use plasma table, go ArcStar.